Part 2 of 3.3, Relative Extrema and the First Derivative Test. So now that we talked about relative extrema and where they occur only at critical numbers, now we're going to actually go through the process of finding relative extrema. And this process is called the first derivative test. And since relative extrema can only occur at critical numbers, well, the first thing you have to do for the first derivative test, which is finding extrema, is to find the critical numbers. So here's the process. The first derivative test, you will determine the critical numbers. Remember, that's where the derivative equals 0 or is undefined. If the derivative changes from negative to positive at a critical number, then you call it relative minimum. If a derivative changes from positive to negative, you call it relative maximum. If it doesn't change, then you know you don't have a relative min nor a relative max there. So we're going to start very simply. This is going to be the first example of a bunch more. So here's a very, very simple example that will give you just the nuts and bolts on how to do this. Let's say x squared plus 4x minus 2. The question here would be, let's find the relative extrema of this function and also indicate the intervals that it's increasing and decreasing. Now, this is going to be an easy example because most of you will realize this is a parabola and it's going to have a because it opens up. But we're going to use calculus to do that, and then we're going to be prepared to do it with more complicated functions. So we're going to use the first derivative test to find out where this has a min or max, and then find out where the intervals that it's increasing and decreasing. So the first thing, step number 1, is find the critical number. To do that, take the derivative, 2x plus 4, and set that equal to 0. Obviously, that will get you x equals -2. That's your critical number. That's the only place, and this is important, the only place that this function can change from increasing to decreasing or vice versa. So, to test if it changes or not, you make up a chart. And the chart will just consist of, top of it is basically a number line, all values of x's. -2 you can put wherever you want. I'm going to put right here. So I like to write my critical numbers up here on top of the chart. And that separates this chart into 2 intervals. This is everything before 2, so everything before -2, so -infinity to -2. That's that whole interval. And the rest of the interval is everything after -2. So that represents -2 to infinity. So the key here is everything in this interval, every derivative in this interval is either going to be positive or negative. It's not going to change signs. It can only change signs at the critical number. So we're going to do a test point. You can pick any number between -infinity and -2. So I'm going to pick, just arbitrarily, say -10. And if you plug -10 into the derivative, that will get you a positive or negative number, which tells you if it's increasing or decreasing. So remember, my derivative is 2x plus 4. So if you plug -10 into that, it's obviously going to be a negative number. You don't care about what negative number it is, just that it's negative. Because that tells you that this function is decreasing on this interval. So I can write this is decreasing on the interval -infinity to -2. Now I'm going to jump over to this interval. I'm going to do the same thing. I'm going to take the first derivative. I'm going to plug in any number on this interval into the derivative. It looks like the easiest number in this interval would be 0. 0 is between -2 and infinity. And if you plug it into the first derivative, remember the first derivative is this, you will get 4. Now, I don't care that I get 4. I just care that it's a positive 4. So that means every test in this interval will be positive. That means we're increasing on that interval. So that's the intervals that this function is increasing and decreasing. To find the actual relative extrema, think about this. We're going from decreasing to increasing. That means we have a relative minimum at the critical number, and at the critical number x equals -2. Now, the last thing, a minimum is the point, the minimum point. So we have to write this as a point. To find this value, you have to plug it back into the original function. So the original function was x squared plus 4x minus 2. I forgot already. X squared plus 4x minus 2. When you plug in -2, you'll get 4 minus 8 minus 2, which is a -4 minus 2, which is -6. And that is the relative minimum. So hopefully you understood that. And it's not, if you think about it, we already knew that this was a parabola. Should have known it looks like this. So that's not very surprising. I'm going to give you a few more examples in the next videos that get a little bit more complicated. But before you go over that, make sure you understand this easy one. And please let me know if you have any questions. Thanks for watching.